Hey guys, and welcome back to the channel. In this video we're going to be looking at 16 AGP video cards that I purchased for 30 euros. The question is, are they any good? Well, we're going to find out in this video. The goal is to see how these cards will fit in my Pentium III 550 MHz machine, currently boasting a Viper 770 TNT2 card, and I actually bought this whole lot of cards just to see if I could improve the performance of my Pentium III rig. Now this is a assortment of cards that I picked up in a big lot, so don't expect any Voodoo 4 or Voodoo 5s here. This is going to be kind of a random sample of the video cards which are out there, and we're going to go over them one by one, taking a look at their feature set, run some benchmarks, and see how they perform overall in the Pentium III based system. In a later video, I'm going to be putting these cards to work in a more powerful system, but for now, let's look at these cards in the Pentium III context. So just going to put all of the cards here in a random order. And to kick things off, I just wanted to talk a little bit about why I decided to buy this lot. It was a very low price point, giving me lots of cards. It gave me an opportunity to look at all of these different cards to see how they would behave in an old Pentium III system and in a more modern system. It was also fun to see if it would be worth the 30 euros that I spent on these cards. So we're going to be going through all of these cards individually, talk about the different chipset vendors, the drivers, how they work, play some games, and so forth. But the first thing I'm going to do is sort them, and I'm going to be sorting them by chipset vendor and by age. And this is the result. So we have an NVidia TNT2 M64, we have a GeForce 2 card, a GeForce 4 card. Then we've got a couple of cards from the FX series. So we have the FX5200. We actually have 4 of them. We have 2 GeForce FX5700 cards. We have a GeForce 6200. And these are basically all of the NVIDIA cards. Then we have the ATI cards with the Rage 128 Pro. We've got the Radeon 9250. And then we've got 3 AGP cards that won't fit in my Pentium III, so I'm not going to be talking about those. And we have a Matrox card. So the test system that we're going to be using is this high-screen Pentium III based computer. It didn't come with a video card, but I had it running with a Viper V770 video card, which is a TNT2 video card. The system originally came with Windows XP, so I thought that that wasn't the most ideal operating system for this rig, so I replaced the Windows XP with a Windows 98 second edition installation. And that is going to be the base platform on which we're going to be testing these 16 AGP cards. Now I might end up splitting this video into multiple parts because otherwise it might get a bit too long. It took a really long time to benchmark all of these things and make sure that I had all the settings right and the correct drivers and making sure that the results made sense. So I do want to talk a little bit about my how I approach this, what kind of tools that I use to do the benchmarking and stuff like that. So we start off with a clean Windows 98 second edition installation, nothing installed yet. So we have the default standard PCI graphics adapter VGA driver installed. Luckily, we also have a network adapter installed, which is supported out of the box by Windows 98, so that will make it easier to copy files across. We also have USB, but we're not going to be using that now. Now, before we take a look at the actual cards and do some benchmarking, I wanted to see what makes a video card great. And this is going to be different for different people. You know, for some it might be important if a video card has a certain output like DVI or a composite or S-Video. For me, VGA is all I need. Some might require active cooling if I want to do like overclocking or something. This card only have a passive cooling system, but obviously there are other cards which have a fan mounted as well, which can help keep the card cool, especially in overclocking situations. Now, another difficult thing with these cards is identifying them. Sometimes they will have this obscure number written on them, which don't immediately tell whether this is a certain NVidia or ATI chip. So you will need to Google those numbers. On the back, you will often see lots of stickers, lots of different numbers, and it can be difficult sometimes to actually see what you're dealing with. For example, here I see an HP part number, so this suggests that this is kind of an OEM-based card which has been pushed to vendors like HP or Dell. So this is probably not the fastest card. You can also tell that this is not the fastest card by looking at the actual chips. So you can see one chip here underneath the heatsink, and on the right we have two memory chips, and on the back we have two additional memory chips. So that's 4 chips in total. Now, assuming that all of these chips are 16 megabit chips, we have 4 of them, so 4 times 16 gives us a 64-bit address bus, which for these types of cards isn't really sufficient. Here, for example, we have a card which also has 4 memory chips, but there is additional room for 4 additional ones. So this card has a 64-bit memory bus, but there is obviously a variant with 128 bits because we can have 4 additional memory chips on this card. So that's very important when you're looking for these types of cards. Depending on the chipset that you have, you might look specifically for 128-bit variants and not the 64 bits as you are seeing here. And especially for this card, because for some cards you definitely need to have their 128-bit variant instead of the 64-bit one. So, which leads us to another very important thing on a video card, which is the actual GPU chip, which is often hidden beneath this heatsink or a fan. Now, as you can see, this heatsink paste has seen better days, and sometimes it is worthwhile cleaning it and applying some fresh paste. But for now, I just want to focus on the GPU chip here. So this is an NVIDIA GeForce FX5200. Now, some might argue that this is the worst video card in modern history. It performed very poorly. It can be found everywhere. You see them online all over the place. Often the 64-bit version as the one you're seeing here. And it's definitely a card that you want to avoid, but I mean, given that there are already 4 FX5200 video cards in this 16 card batch, gives you some idea on, how the market has been flooded with these cards. Now, the type of video memory that the card has is also important because older cards will typically have SDR chips or single data rate chips. Others will have DDR chips, which are effectively double in speed, which gives it a nice performance boost also. And one final note, sometimes the caps on these video cards tend to fail, so either you will see them bulging like this one here. As you can see here, it is definitely not looking pretty, especially not compared to this one, and that's probably the reason why this particular card no longer boots. So I've created this nice little overview here of all the cards. I think it's very important that you kind of see these cards in context, so I've also added the date when these cards were released. It's very difficult to compare a card from 1999 to a card from 2005, but as we are going to be putting them into a single machine, which is basically a 1999 2000 based Pentium III machine, it's very important that we put that in proper context, because as I will show you later, it doesn't necessarily mean that a card from 2005 will be a lot faster than a card from 1999. There are lots of different aspects involved, like driver versions, compatibility with the operating system, with the BIOS of the computer and stuff like that. Now, before we go ahead and benchmark, installing the proper chipset drivers for your system is also of vital importance. We want to make sure our system is up to date, and I am looking forward to seeing how this VIA-based chipset will perform with these video cards. Now, if we're going to be benchmarking a lot of cards, we want to get a good idea on how the actual system as a whole is behaving. So we're going to be needing a couple of tools. Now, cpuz is a very handy tool to give you some additional information on the CPU which is in your system, and also give some information on the motherboard, memory, and GPU. Now, the standard version doesn't run on Windows 98 anymore, so you need to search for a specific Windows 98 version, but they can be found online. The version that I have is version 1.76, and as you can see here, it has detected my Intel Pentium III, got my 550 megahertz CPU. We get some information on the level 1 and level 2 cache. We can see the MSI motherboard here with the VIA Apollo chipset. We can look at the memory timings, and we can see some basic information on the GPU, not a whole lot. So for that, we're going to be needing another tool. But before we look at that, I also wanted to show you Hardware Monitor, which is also a very popular tool. Unfortunately, it doesn't work on Windows 98. There is a version for Windows 98, but I have yet to find a system where it does work because it doesn't find any sensor information, making it pretty useless. Now, Everest Home Edition, on the other hand, is a very useful tool, because besides showing you lots of information on the computer, it also has a dedicated GPU section where it can find lots of information on your graphics adapter. Stuff like the GPU clock, the memory bus type, the type of RAM, the memory clock, all of that information is available here. I'm not saying that it's always 100% correct, so you need to do your due diligence and search for yourself, but in most cases it will be able to find something about your graphics card. Now, another useful tool is in Windows itself, and that is the device manager. So when you click on your display adapter here, you can select the driver tab, you see the driver date, and when you go into the actual driver file, you can see the file version as well. So that's also very handy. Another very useful tool is RivaTuner. So this works with both NVidia and ATI based cards, and it allows you to tweak lots of direct 3D and OpenGL based settings and optimize the working of your video card. I usually also install PowerStrip, which is kind of a similar tool. It has some overclocking capabilities, and it also allows you to kind of tweak your direct 3D and OpenGL based settings. I usually triple check these settings also with the built-in NVIDIA or ATI driver, because sometimes you think you've enabled or disabled something, but then something else has overridden it. So it's always best to kind of triple check all of these settings. Now, you don't only need to use those third-party tools, because typically your driver itself will also have some properties. So if you go into the advanced display properties, you will typically find, for example, in this case, it's the GeForce 4 MX panel here, which also allows you to tweak direct 3D and OpenGL based settings. So there's a lot of overlap in these tools. Some tools can do more than what the standard driver can do. So yeah, I think it's always very useful to have these things installed and just getting better insights in how the system works. Here you can see something similar from ATI. So this is my Rage Fury Pro card, which is installed. It has some direct 3D settings, for example, the VSync that you can turn on and off. Very important when doing benchmarking, because disabling VSync will allow your benchmarks to achieve higher frames per second than they would usually do, because otherwise your application, benchmark, or game would try to sync up the actual frame rate with the refresh rate of the monitor, which is typically something like 75 Hertz. So that would mean that it would never surpass 75 frames per second, meaning that your overall benchmark score would be lower. And this can be seen here in 3D Mark 99, where I did a benchmark with the MX440, one with VSync turned off and the other with VSync turned on, and you can see a substantial performance difference in some of the tests, which will result in a higher or lower benchmarking score. And this gives us a nice segue into the benchmarking tools that we will be using on this system. Now, because this is a Pentium III based system, I'm going to be using 3D Mark 99. Now, I'm not really sure if this is the best choice, because I have the impression that these newer video cards with the newer drivers don't perform all that well with 3D Mark 99. So I'm getting kind of bizarre results with these newer cards. So I've decided to also add some games into the mix. Now Quake 3 Arena has a built-in benchmark. You can see here I ran it and it came up with 43.5 frames per second. Now this was with the sound turned on, and in Quake 3 you can actually disable the sound using the sinitsound0 command. You then restart the sound device, and if you then relaunch the same benchmark, you will actually see that your frame rate will have increased substantially. For example, here I'm doing another run, and what I noticed was that with the exact same settings, you know, in the exact same conditions, I didn't restart the system, I didn't change or tweak any settings, I actually got an increase in the overall average frame rate of this demo with over 5 frames per second. So it actually increased from 43 to almost 48. Expandable is also a nice game which has a built-in demo, so you can execute the go command with the -timedemo1 argument, and it will activate an automatic benchmark where the system will just loop through a level and it will display the current and the average frame rate. So this is also a nice benchmarking tool. Same thing with Unreal. We're going to be using the city intro that you can time demo here using the console. So you type in time demo1 open city intro, you hit escape, and it should start the open city intro with, again, the average frames per second, which will be shown on the screen. You have no idea how many times I had to sit and watch this city intro, or the Quake 3 Arena time demo for that matter. I mean, it is very time consuming to benchmark and test all of these cards using different resolutions. So here in this case, Unreal will show you the average frame rate, and you can loop this a couple of times and then just average it out. Another thing you need to deal with when testing lots of cards on the same system is that you need to change and swap drivers a lot. And this will often result in like startup failures, drivers not being found anymore. And trying to remove drivers is not always that easy. For example, here I failed to uninstall the NVidia drivers at some point. So there are some dedicated tools that we can use for that. For example, Driver Cleaner Professional is one of those tools that runs in Windows 98. It's a very simple application to install. And when you launch it, you can select your favorite vendor for which the drivers you want to remove from the system. So my guess is it has a couple of templates for all of these different vendors, and it knows where to look for certain files, registry entries, and it will basically just go ahead and remove all of these files, all of these registry entries, drivers, and give you a cleaner system afterwards. Sometimes it is necessary to do this in safe mode because sometimes driver files will be in use, but it does an overall good job of cleaning drivers and making sure that you can delete either newer drivers or older drivers for the same card without messing up your system. And another thing I found really annoying with the NVIDIA drivers is that all of a sudden my File New menu item was gone, and my right-click context menu also didn't contain the new folder entry anymore, which was very annoying. And this is caused by some kind of bug in the NVIDIA drivers. Now there is a way to get that new folder menu item back. For that you need to go into the registry. So we're going to go into let me see what key this is. So I think it's directory, background, shellx, context menu handler, and there we can add a new key. We're going to be calling this new, and we need to give it a key value, which I have written down here. So this is a hex string that we need to include. Hit OK, exit the registry entry, and we can again create folders here. So file new folder works again. So this is great. So we've ran out of time for part 1. I am going to be doing the actual benchmarking of all of these cards in part 2. I would be very interested in hearing your thoughts on these video cards. Do you think they will improve the overall performance of the Pentium III system? Is it a good fit for a Windows 98 build, or would they fare better on a more powerful system? I am planning to test these on an Athlon-based system also, just to see what kind of performance gains we can get between the individual cards. I have done most of the grunt work now for part 2, so normally all my numbers are ready. So I hope to see you guys in part 2. It should be dropping fairly soon, and I hope to see you guys then. Bye-bye.